All right, welcome back to Anatomy and Physiology as we continue to talk about movement and joints. Uh, we're talking about the structural classifications of joints now. And remember that what we talk about as it relates to the structural classification of joint is based on what the articulating surfaces are connected by. So you can see here that binding materials might be what it's called. There is the fibrous joint, which is held together by a dense fibrous tissue, collagen fibers holding them together, densely interlocking. There are cartilaginous joints, which are either held together by hyaline cartilage or fibrocartilage, and then synovial joints, which are ultimately separated. Right, these are ones that have a space. There's a space between the two bones, and there's synovial fluid in between those spaces. You can see there's a cavity present in synovial joints. So that's the idea, is that there are fibrous joints, and fibrous joints are held together densely by fibrous tissue. We'll take a look at that shortly. We'll also talk about these cartilaginous joints before we talk about synovial joints. And synovial joints we'll talk about separately because there's very much more specificity as it relates to synovial joints. So let's talk first about those fibrous joints. And so fibrous joints, as we've mentioned, are held together by dense fibrous connective tissue. There are three types of fibrous joints: sutures, as you can see here, syndesmosis, and a gumphosis. And so, one thing that I do want to say is that the main common structure here is a ligament, right? There's fibrous connective tissue holding two bones together. So what you're going to see is a sutural ligament, a ligament that holds these bones together, an interosseous membrane, or even a periodontal ligament. So it's a ligament there that holds these bones together. So uh, a wide sheet of connective tissue, or even a densely held together. But the first is a suture, and sutures are only seen in the skull. They're a classic example of a synarthrosis, an immobile joint, and they're held together by a sutural ligament. There's dense fibrous connective tissue holding them together. A syndesmosis is a joint that's held together by a ligament that actually can vary in length, but ultimately it's longer than a suture. And so in this structure, there's actually two syndesmosis. So again, because we've mentioned that it can vary in length, there's a syndesmosis that will hold these two bones together. See if I can, right here. So there's going to be a syndesmosis here, as well as a really dense band of connective tissue that you can see here. So there's and we'll kind of finish that there, right? That band of connective tissue that holds the two diaphyses together, right? The two lengths of the bone, but also that holds the epiphyses together as well. So there can be two types of syndesmosis. And then finally, a joint that is specific to the teeth. It's referred to as a peg and socket type of joint. This is a gumphosis, a specialized fibrous joint in which the periodontal ligament, remember we mentioned that the common uh, connection here is a ligament. The periodontal ligament holds the tooth into the bony socket, whether it's your maxilla, the upper jawbone, or your mandible, your lower jawbone. And so Again, due to the immobility of this gymphosis, it is functionally also referred to as a synarthrosis. Now, cartilaginous joints are held together by cartilage. And now there's two specific types of cartilage, not necessarily elastic cartilage, but hyaline cartilage is a big one. And then fibrocartilage. So, as you may or may not see here, the bones or the joint related to a synchondrosis is a joint that's held together by hyaline cartilage. So a synchondrosis is a bone or a yeah, where bone is held together by hyaline cartilage. And I had a little bit of trouble defining this because the epiphyseal plate is an example of a synchondrosis, but it's only a temporary synchondrosis, right? So remember that the epiphyseal plate sits right here, and that epiphyseal plate is hyaline cartilage. So where you have the bone of the epiphyses, so this is bone, right? And then there's bone below. There is cartilage between them. So that's a temporary synchondrosis where you have the bone, cartilage, bone connection up the epiphyseal plate. Another example is, and probably maybe a better example, is one of the rib and the sternum. So your ribs and sternum are held together by cartilage. We'll just kind of click on this example here. So specifically, we're looking at the ribs and the sternum, and you can see here that there's a part here. This is cartilage. This is not bone that holds the ribs together. So you can see that there's cartilage there. And so again, another example of a synchondrosis are the ribs associated to the sternum. And then finally, the cartilaginous joint where bones are joined by fibrocartilage is called a symphysis. Now, fibrocartilage is very strong because it contains a lot of bundles of those thick collagen fibers, which give it an ability to resist tension or pulling compared to the hyaline cartilage. But also, there's a little bit more movement as well. So, the symphyses that ability to strong unite bones, but can still allow for limited movement to occur. Thus, this symphyses are usually classified as amphiarthroses. And so now, this example you can see here in these examples, you can have a narrow symphysis or a wide symphysis. So you can see more of a narrow symphysis might be like your pubic symphysis or the manubriosternal joint, right here where there's a small space between them. And then maybe a greater space in between them might be the intervertebral disc. So the intervertebral disc is made up like a how do I put this like I hate to say like a jelly donut, but on if we're looking at it from the top from the superior, what you're going to see is that there's an two rings inside of the intervertebral disc. On the inside is called the nucleus pulposus, NP for short. I'm going to put NP here. And that's more of the gelatinous material that holds that gives it a little bit more cushioning for compression, kind of like a little bit of like hydraulic component, right? And then there is a fibrocartilage that runs on the outside, the outer third to half of the intervertebral disc is fibrocartilage. And so that is kind of the bone disc bone connection, is the outer portion of the intervertebral disc. On the inside it's like that jelly donut, it's got the nucleus purposus. On the outside it's got fibrocartilage holding it, and even those fibers are oriented in a fashion to protect too much movement that occurs from the spine. And so that will uh, finish up this portion here where we've talked about the structural classifications of the joints and how they relate functionally. Primarily, we talked about fibrous joints and cartilaginous joints. Stay tuned, because for the rest of the chapter here, we'll be talking primarily about synovial joints and how they move.